In the last episode, we saw why Kubernetes uses a feedback loop. Humans describe the outcome, and the system keeps moving reality toward it. But that promise hides two important questions. Who notices that reality has changed, and who decides what to do next? Let us return to one simple promise: keep 5 copies of an application running. At first, all 5 pods are healthy. Then one pod disappears. The desired state has not changed, but reality has. A failed pod does not create its own replacement. The promise of 5 is only useful if something can notice that the count has fallen to 4. That watcher must know both what was requested and what currently exists. A human could check one application occasionally. But a real cluster may contain thousands of objects changing all day. Pods start, nodes disappear, releases move forward, and traffic rises and falls. Human polling cannot be the control loop. Kubernetes solves this by assigning the job to a controller. A controller is a long-running program with one narrow responsibility. For our example, the replica set controller is responsible for keeping the requested number of matching pods alive. The controller does not log into every machine and inspect containers one by one. That would tightly couple it to the runtime and to every node. Instead, it works with Kubernetes objects through one shared boundary, the API server. The API server gives control plane components a shared view of Kubernetes objects. The desired count is recorded in the replica set. Existing pods and their reported status describe the current state. The controller can read both without knowing which machine reported each detail. The controller does not repeatedly ask the API server every millisecond. It opens a watch and receives a notification when relevant objects change. But the event is only a wake-up signal. The controller still reads the latest state before making a decision. Now the replica set controller performs its real job. The replica set says 5 replicas should exist. And the latest pod records show only 3 active replicas. The difference is 2. The controller does not start 2 containers itself. It asks Kubernetes for 2 more pod objects by writing through the API server. This is an important boundary. The controller decides the required change, but other components carry it out. The new pod objects still do not identify a machine. The scheduler chooses suitable nodes. Then the kubelet on each chosen node asks the container runtime to start the containers. The controller remains focused on replica count. Once the containers are running, the kubelets report pod status back through the API server. The replica set controller sees the new state, counts 5 active pods, and finds no remaining gap. One pass of the loop is complete. Here is the power of the design. The controller does not need a different recovery script for every cause. A pod may crash, a user may delete it, or an entire node may disappear. In every case, the observed count becomes smaller than the desired count, and the same reconciliation logic runs again. Kubernetes does not place every decision inside one enormous brain. It uses many focused controllers. For example, replica set controller maintains replica counts. Node controller reacts to node health. Deployment controller manages rollouts. Each controller watches the objects it understands and closes one specific kind of gap. This makes a controller very different from a script. A script assumes that its previous step succeeded and the world has not changed. A controller makes fewer assumptions. Every time it runs, it reads the latest state and asks what is still needed now. So who watches reality? Controllers do, by watching the shared cluster state exposed through the API server. Who decides the correction? The controller responsible for that relationship. It reads, compares, writes a corrective request, and then checks again. But this architecture creates a new puzzle. The controller, scheduler, kubelet, and users all communicate through the API server instead of calling one another directly. Why add this layer of indirection?